So let's move to the second scenario. The second scenario also talking about one of the Ghana's ambulance moving with a velocity is given by the function v of x equal to 3x, where x is in hours and v is in miles per hour. They said we should use geometry to find the area under the graph, which is the distance the ambulance has traveled. Which is the distance that the ambulance has traveled. So how do we do this? So first of all, let's see something here. We have been given let's see something here. We have been given the function, which is the velocity of the ambulance, which is v of x equal to 3x, where x is in hours and then the v is in miles per hour. So using geometry for this, the graph, we can get a clear overview by sketching some simple graph. So let's sketch some simple graph over here. So this is our t and this is our v. This is our t and this is our v. So let's see something here, right? We can label our x-axis here from 0. Maybe let's start from here. 1, 2, 3, 4, 5, right? And then we can also do same for x as y-axis, depending on whatever we want to do from here. And now, what we can do is that we need to plot this graph. So at x-axis, y is equal to 0. So if v of x, it's representing the y. Therefore, at x-axis, y equal to what? 0, and therefore we can say that our 3x is equal to 0, and therefore our x is equal to 0. And then at the y-axis, our x is equal to 0, and therefore we can see that our y or v is equal to 3 times 0, which is what? 0, and therefore our point is 0, 0. So that's where the starting point is coming from when you are plotting it. So it's passing through the origin here, and now the velocity was increasing. So if we put in 1, if our velocity of v equal to 3x, and now our x is equal to 1, we are going to get a value. But the question is asking us during the first 3 hours. So if you want our equivalent v value, the velocity at which it traveled at 3 seconds, what do? We substitute it inside. So what we are going to get is 3 times 3, which is what? 9. That will be our y value, equivalent y value, or the velocity. So now this is what we are going to have, and this is what we are going to have. We have 9 here. So now we have 9 here, so we can see the figure is a triangle, and then the area of a triangle is equal to what? Half base and then height. Now half our base here becomes what? 3 minus 0, we get 3, and then our height is what? 9. So from here, what do? 3 times 9 will give us what? 27, and then divide by 2, then we are going to get 13.5 miles. So now this is the distance the ambulance has traveled at 3 hours. At 3 hours. So let's consider the second scenario. So it said between the 3rd hour and then the 5th hour. So if you look at this place, we can see this is our 5th hour. Yeah, our 5th hour. So the same, it starts from 0 and it will move here up to this place. But if you want our equivalent velocity value, we want to put in the 5. So 3 times 3x, right? 3x is equal to 3 times what? 5. And therefore, let me use dot so that I don't confuse the x. 3 times 5 equal to what? 15. So now, 3 times 5 is our equivalent velocity for the second one, right? And then the same thing, they say is between the third one and then this one, and then when we look at this one as well, this one as well, we are also going to get 3 times v. The second one is 3 times 3, which is what? 9, right? So you can see that here we have a rectangle inside and we have a triangle inside, considering this top. So here is a triangle and here is the rectangle. So for the rectangle, we can calculate it straight away from it, which is what? 5 minus 3. 5 minus 3 times, and from here to here, it's what? 9. So 5 minus 3 is 2 times 9 is what? 18. And now let's look at the triangle. So the triangle part, when we substitute this for the whole of this length here, we are going to get 15. And we substitute the whole of this length here, we are also going to have 9. And this is the height that we want from here to this place. Therefore, we are going to get 15 minus 9. Or let me write it here, 15 minus 9. And now we are going to get what? 6. And therefore, area of a triangle is equal to half base times what? Height. So half, the base is what? 2, because 5 minus 3. And then the height is what? 6. So now this will cancel, and we're going to get what? 6 miles. And in total, the area of the triangle, right, plus the area of the rectangle, right, will give us what? 6 plus 18, which is what? 24. So in all, the car traveled, or the ambulance traveled at a distance of what? 24 miles between the 3rd hour and then the 5th hour. So this is the interpretation of whatever you have gotten. We have a lot more 2 scenarios to go, but because of time, I'll leave the other 2 for you so that you can do here. Mr. Joshua's tech point named the marginal profit and the marginal profit function, which is modeled by the linear function P prime x equal to 0.15x, where x is in months and p prime is in thousands of dollars per month. Sketch the graph and use it to determine the total profit earned by Joshua's tech point in a year. So this is a solution. You have a solution here. So basically, what I want to do is that I'm not going to do this question, but what I'm going to do is that I'm going to give you a clear overview so that you can know what to do. So this is your marginal profit function. As we did for this one, follow the same procedure. That's it. Just plot your function. Just plot it on a graph. At x equal to 0, y is 0, and then at y equal to 0, x is 0. So from 0 to that means it will start from the origin. So if it's starting from the origin and they are asking us in the thousands of dollars per month, sketch the graph and do this. So in thousands of dollars per month in the year, so how many years in the months is in the year? So that's 12. That means your N1 is going to be 12, and then down the day you are going to get something like this. You are going to get something like this, and what you need to do is just use, if you want to convert to hours, you can use, or you want to convert them into years, you can use years. If you want to use it in months, you can use month, and then find the area, half, base, times height. That's all about the Joshua stake point. And then I think that's a last one that I wanted us to talk about. Yeah. So now let's consider something here. So how do we approximate the area if the rate is a curve? How do we approximate the area if the rate is a curve, but not the normal figures that we see here? If the rate is a curve, how do we compute this area? So in this case, the area function is an antiderivative of the function that generated the graph. And therefore, how do we handle such curved graphs for which this area formula may not be known? And this is where the Riemann summation comes in. So keep watching, and my next tutorial will be about Riemann summation, and we are going to delve deeper into how we can use Riemann sum to approximate the area of a function. And if time permits, I also try and use GeoGebra to do Riemann sum so that you can also get yourself involved in a bit of technology to know how you can use technology to do integration. Thank you, and see you in my next video.